Alright, in this question they tell us the center of a circle O is at the origin from external point A. Here's A, they label it for you. Tangents AP and AB are drawn to the circle at P and B. Notice they give you these points 5, 0 and negative 3, y. So we know we're on a coordinate grid. So that means O, the origin, is actually at the point 0, 0. And this tells you some critical information. If you draw a radius from the origin to the point P, right, you actually know how long that is. That's 5 units because you're going from 0, 0 to 5, 0. And I feel like in general with this problem, the fact that we're on a coordinate grid allows us to solve it pretty quickly. So here's the reasoning I used. Once you know that's 5, I know that if I connect these points here, that's also 5 right there, right? So radius as well, the same value. And I was trying to, you want to find the value of y. So you want to find out how far down we're going, right, to get over to this point. And down, you're going to go over 3 units to get back at this point. So this point B is at negative 3, and that means, again, it's 3 units back from the point at the origin. So if we just step back 3 units here, right, we know we're going to be at the same location as this point down here because it's 3 units back from the origin. So if we think about the way a coordinate grid works, then if we draw this vertical line, these 2 points are both at that location 3 units back from the origin. Also, you notice at this part of the circle, there's another point 3 units back, right, from the origin. So there are going to be 2 answers here. Don't be deceived. A could be up here as well. It could be a point up here. That would still meet your point P, right, and B over here. We don't know where B is. Right, so the actual physicality of the diagram doesn't actually restrict us. The numbers don't restrict us, right? Even though physically it looks like it can only be at these 2 spots. So what's the value of y anyway? Well, if you go back 3 units, right? Oops, here's my line tool. If we go back 3 units here, right? And that's a 3. We then are struck with this idea as, oh, at least I was struck. I am always looking for these Pythagorean triplets, right? If this is a 3 here, I'm like, oh, couldn't this just be a 4, this leg right here? And is this a right angle? Well, the wonderful thing about being on a coordinate grid is that, yes, we have the right angle there, right? The way a coordinate grid is set up, this horizontal and vertical line, they're perpendicular to each other on the grid. So if we go over 3 in this direction and then go down some direction here, we're going at a right angle, right? That turn from left and right to up and down is 90 degrees. The same thing is true up here. So we know we have these right triangles. We know the hypotenuse here, this radius is the hypotenuse, is 5. We know one leg is 3. What's the other leg? Well, we can use the Pythagorean theorem. 3 squared plus some other leg, b squared, has to equal the hypotenuse, 5 squared. Right, that's 9 plus b squared equals 25. Solve for b squared, subtract 9 from both sides. B squared is 16, and we get positive or negative 4 equals 16. I'm sorry, positive or negative 4 is equal to b, right? Take the square root of both sides, so I'll write that step in. Square root of b squared equals the square root of 16. The square root of b squared is b. The square root of 16 is positive or negative 4. It could be one or the other. And we can accept both, because b could be up at this point as well, at positive 4, or down here when y is negative 4. So those are the 2 answers, the 2 points you can have. And again, when you look at point A to the point of tangency, that's one point that meets the circle. You might think, oh, there's no way I can get up here from point A because I have to cross the circle twice, and a tangent line can't do that. But A could be up here as well. A is not given any positive or negative value whatsoever. All right, thanks. Hope this helped.